Okay, today let's talk about 4.5D, and basically we are going to complete the equation for graphing sine and cosine graph. So we've already talked about vertical shift, we already talked about amplitude, all the other components. Well, today we're going to finish off all the components. The final piece of part of it is the horizontal shift back and forth. Let me put this in some idea of another equation. Let's put it in y equals x squared. So our basic y equals x squared, our actual formula for the vertex formula is y equals a x minus h squared plus k, whereas h and k is the vertex and a is the amplitude, but the h it's where it moves left or right. So in similarity, our sine equation is similar to that, whereas our sine equation is actually y equals a sine b x minus h plus k, where now, or in other places, h and k is d and c, but it's kind of the same thing. So here, a is our amplitude and b is our phase. So b is the phase, k is our vertical shift, and now finally our h is going to be our horizontal shift. So let's do two examples that kind of look alike but are not. So let's say we have two different equations here. Let's say we have one that is, let's go over here. One that goes y equals sine of, let's say this is 2 times x minus 2 plus 1. So here, this is very important because the 2 and the x minus 2 are together within parentheses. Now let's put in a different one. So let's say we have the other one being y equals sine of 2 x minus 2 plus 1. Well, they look alike, but not quite. So one of them is, it's the true form. So this is the true form. The other one, this isn't completed because even though it's within that bracket, the 2 needs to be factored out between the 2x and the negative 2. So that one is actually y equals sine of 2 parentheses x minus 1 plus 1. So those are the two different types of equations. So if we graph this here on the side, and let's start with our simple graphs here. Let's say we have, so this, we'll say this is 1, and we'll say this is negative 1. Since this is all adding 1, we're going to shift everything up 1, so we're not going to have to really worry about the bottom part. This is 2. So here our vertical shift is 1 for both of these, so we're going to start up at 1 is going to be our center here. From here, let's first condense our graphs first. So our original graphs would go from 0 to pi. Well, let me use blue here. Our original ones goes from 0 to pi over 2 to pi to 3 pi over 2, then back to 0 again. So that's one whole phase. But now, since our phase is being multiplied by 2, we divide, right? So we divide by 2, so it shrinks. So instead of going from 0 to pi, we start off at 0, and then we go to divide that by 2. So this is pi over 4, pi over 2, and then 3 pi over 4, which is now our new phase, our condensed phase. Now the whole thing gets shifted over a 2. So not just a pi, so not a unit of pi, but 2. So technically here, everything gets added to. So the new starts at 2 pi over 4. I'm going to convert this to regular numbers so I can just add 2 to it. So 2 plus pi over 4 is actually 2.785. Pi over 2 added to 2 is 3.571, and then 3 pi over 2, or 3 pi over 4, add 2, because this is pure numbers now, because we're just adding a number and not with a pi. Had it been a pi, we could have put in our units as pi, but that's not what happened here. Is 4.65. So here, to make my life easier, I'm gonna graph it like this. So if I said, hey, we're gonna call this part here, so it's from 2 to 4-ish, so we'll just say this is 1. Oh, let me put that in black. 1, 2, 3, -1, -2, -3. So if I then graph this at 2 is where it's the 0, and then at 2.7 something, so it will be up here will be the peak, then 3.5, and that will be down here. If I notice it goes about 0.785 each time up, because 2.75 minus 2 is 0, so it goes the same. So if I did 2 minus 0.785, the next one backwards is 1.2 something. So that's down here, and then I keep subtracting 0.785. I get 0.43, which is then about here. So keep subtracting 0.785, and then it's -3 point something. So this is about here. So it kind of looks, if I connect it, and I continue the idea, it kind of looks like that. Now, if I did that for the other one, my phase shift, so the phase shift is going to be the same, but now the horizontal movement is just moving over to 1. So where originally the 0 is at 2, the 0 is now at 1. And since the phase shift is the same, we just add 0.785 to each one. So this 1 is 1.785, 1.785. So the next one should be plus 0.785, 2.571, 3.356. So here, this one at 1 is where the 0 is at 1.7 is where it goes up to the top, so 1.785. So here, and then it goes down at 2.5 something here, And then at 3 point something, it goes down here. So this is the other. So if we kind of repeat that a little, is what the other one. So the phase shift is the same, the vertical shift is the same, the amplitude here are the same. The only thing different, because there is a parentheses in one and not in parentheses in other, is the horizontal shift.